Okay. So 3-3 is now finding the surface area of specifically pyramids and cones. Okay, so in the last section we found surface area of prisms and cylinders. Okay, that wasn't so bad. So it's not going to be completely different. Now we just have a different shape. We've got a regular pyramid, and then we'll do cones. So this is a nice little drawing of a regular pyramid. So the base of this particular pyramid is in the shape of a what? Of a square. Okay, so remember that when it says a regular pyramid, that whatever the shape is that's on the bottom, the base, all of the sides are the same length. Okay, so it's possible to have a triangular pyramid.
So all of the triangles are congruent?
Yes, of the lateral sides, yes. And then on the base, all sides are the same. Okay, so you could have a square. If you had more than 4 sides, you would have a pentagon, and then a hexagon. So whatever it would be, all of the sides would be the same. Okay, so this picture of the lateral area, I think, is really a good visual. Okay, so it is important that we see, number one, where those links are coming from. Okay, so you guys see that the S's, there's 4 of them because there are 4 sides of our square. The height of that rectangle is in the length of L. Okay, so does everybody understand that L stands for the lateral length? Okay, and it is not the height of the pyramid. Okay, it's like the diagonal from the tip of the cone to the end, to the edge. Does that make sense?
Yeah.
Sort of, kind of? Okay. Yes. All right, so if we were going to just find the lateral area and come up with an equation for this particular pyramid, what would the length of the base be?
S. 4.
Close.
4S times 4.
4 S's. Okay, so the length of the S, the length of the base would be 4 S's. Okay, so 4 of them, right? Okay, and then if I was finding the area of the whole rectangle, I would say, well, the area of the whole rectangle is 4S times L, right? But if we're just looking at the triangles, what do you notice with the triangles compared to the complete area of the whole rectangle? Hey, Bailey, do you mind hitting that door for me? Sorry, I don't know if that's distracting to anybody else, but...
Does it make up half of it?
Thank you. It makes up exactly half of it. Perfect. Okay, so the area of just the triangles would be 1/2 times the base, which is 4S, times its height. Okay, so this turns out to be our lateral area. And we could even make that even more simple. What's 1/2 times 4?
2.
2. So 2 times S times L becomes the lateral area of a regular pyramid as long as the base is a square, right? Okay, so if we then include the whole surface area, okay, so notice they wrote this as 1/2 times perimeter times L, which we just made slightly more simple and said 2 times S times L. So we could replace that piece with that. Okay, so to come up with the complete surface area, we just are going to include the base. Okay, so if our base is a square here, the side's length of S, what could we replace the B with? S squared. Okay, so that would basically be a little bit more simple of an equation. Okay. Okay, so let's do it. Okay, so in this notes, if you guys go to my website, you can see this page literally. If you want to see an example, it's there for you to see. I'm not going to go over the example. I'm just going to bypass it, and we're just going to do one together. Okay. All right, so let's find the lateral area of this regular pyramid, okay, with a base that is exactly a square. Okay, so let's go ahead and find the lateral area first. Okay, so what was the formula that we just wrote down for the lateral area of that regular pyramid?
2SL.
2SL. Okay, now if I fill in the missing pieces, what is the length of the S?
Is it 8 or is that the height?
The 8 is the height of the pyramid.
It's not that.
It's not that.
It's L.
Well, we can fill in the S right now.
6.
6. Okay, so the sides are length 6. Okay, but how am I going to find the length of L? Good. Okay, so you see that right triangle that kind of exists inside of there? Has a height of 8, and this base right here is going to be half of 6, which is 3. So that's how I'm going to find length L using Pythagorean's theorem. Okay, so you guys remember length squared plus 8 squared plus 3 squared would be, let's see, 64 plus 9, which makes, let's see, 73. So what's the square root of 73?
8.5.
8.5 exactly?
8.5440.
Let's go 2 decimal places. That feels more accurate. So we'll multiply this by 8.54. Okay, so what's 2 times 6 times 8.54?
102.48.
102.48. Good. Okay, so then if I'm going to complete my surface area, I would just add the lateral area that we just found and add the base of that pyramid. So since my base is a square, can we go ahead and say the area of a square is 6 times 6?
Yep.
And just say 36. Okay, so 138.48. And we should label our increments. We're going by feet, so feet squared. Not too bad?
Yeah, it's way easier than cylinder.
Really?
Yeah, the cylinders are
Okay, I want to do this one also because this is slightly different shape. It is a pyramid, but this one is a triangular pyramid. That base, the base of that is an isosceles triangle. So all 3 of those sides are the same. Okay, so what? Or an equilateral. Excuse me. Thank you for catching my mistake. So let's start with finding the lateral area. Okay, so if I'm looking at one of the faces, okay, that has this height of 6 and a base of 4, how do I find the area of this particular triangle?
2 times 6. Half base times
Okay.
height.
Okay, so 1/2 times 4 times 6. So 2 times 6 becomes 12. Okay, and then how many of those sides do we have altogether? 3. So if we take 12 and multiply that by 3, that will be the total lateral area. So we would have 36. Good. Okay, so now if we include the base, now let me draw the base as an equilateral triangle. 4, 4, 4. Okay, what do we need in order to find the area of this triangle? The height. We need a height. Okay, so we cut that in half. This leg would be 2. Okay, so we're going to need Pythagorean's theorem again. Okay, so we're going to need, let's see, 4 squared is equal to h squared plus 2 squared.
That'd be 1.
It's gonna be not so nice. It's gonna be like a decimal number.
4 squared. 16.
Oh, 16, yep, excuse me.
The square root of 12.
So the square root of 12, right?
3.46.
3.46. Okay, so then the base area is going to be 1/2 times the base. So what's the base length of that green triangle? 4 times the height, which we found, 3.46, would be 6. 6.92.
No, 6.
Oops.
6.9.
Goodness gracious.
I bet you wrote that.
6.92. There we go. So then if I just add the lateral plus the base, so we got 36 plus 6.92 will give us our total surface area to be 42.92, and we would label that centimeters squared. So how was that one? That one was a little bit more confusing because you had to find a missing piece. Not too bad. Everybody good? Check. Easy. Oh, okay, good. All right, so that's see if we got the right answers. 42.9. Good. Okay, so those were pyramids. Okay, so the second half of this is finding the surface area of a cone. Okay, so the book takes you through how you come up with the formula for the surface area of a cone. So if you're interested in understanding how they come up with that, feel free to go back and take a look. I'm going to do the fast forward method and give you the formula. Okay, so the formula for the lateral area is right here. Pi RL, pi times the radius times the lateral length. Okay, and then to find the surface area, you just add on the base, which happens to be a circle, so pi r squared. So make sure you have both of those written in your notes. Those will be easy formulas to just pull. I would probably like highlight them, star them, make them easy to find. Good there? Good? Okay, so here is an example of how to, which I'm going to skip, but feel free to go back to if you so desire. So we're going to do this one together. We're going to do number 7. Okay, we're going to find the lateral area of this cone first, and then add and find the surface area. Okay, so what was the formula you just wrote down for the lateral area? Pi times r times L. So, looking at our picture, what is the r? 3, good. And what is the L? We don't know yet, right? So we're going to have to do Pythagorean Theorem. Let's see, we got a 4, 3, ooh. Anybody know the hypotenuse of that? 3, 4, 5, right? So you can do Pythagorean Theorem and find that hypotenuse of 5, or you can just remember 3, 4, 5 is always an easy one to remember for a perfect right triangle. 3, 4, 5. So that lateral length is a 5, so I'm going to plug that into my formula. So I've got pi times 3 times 5. Who's got a calculator? What's pi times, or just call it 15 pi?
47.123. 124.
124? Okay, I'm going to go 0.2. All right, so to come up with the surface area, I would add my lateral area plus the area of the circle, that base. So area of a circle is pi r squared. So we just said the r length was 3. So we square that. So if you add 9 pi to what you just had, what do you get? 27 inches squared. Uh-oh. Oh yeah, that doesn't make sense. So maybe add 27.
Oh wait, 9 pi
Is 27. So yeah, so add that to 47.12.
$75.39.
There we go. That makes more sense. And we can even double check that. Let's see. Perfect. They got 75.4. We'll call that good. Okay, so we good there? That one's actually pretty easy. The cylinder is, there's not much you can do with the cylinder. Okay, so do I need to do example number 8 when they give you the radius as opposed, or the length, and you have to come up with the radius? So you would just have to do Pythagorean Theorem to find the radius. We're good. Piece of pie. You guys get it? Alright, so the last piece, of course, that they're going to throw in these composite functions where they just have to add all these cool shapes together. So there's an example of a couple, if you feel free to go and check those out. We're going to do number 10. Okay, so this is like a double cone on top of a cone, a big cone on a little cone. Okay, so how are we going to do the surface area of this double cone? Find lateral areas. What about the bases? Do we need to find the bases?
Just one base.
So are the bases on the surface of the shape? Yeah, so we don't even need to add the bases at all because the bases are inside. All we want is the lateral area of the top cone and the lateral area of the bottom cone. We don't even need those bases. Okay, so let's do the top cone. Lateral area of the top cone. So what was the formula again for the cone, the lateral area? Pi r L. So pi, my r for this one is 4. What's my L?
8.
Let's see. 8 squared plus 4 squared is equal to L squared. 64 plus 16 is 80. Anybody know the square root of 80? 8.94. Just throw that down there, 8.94. So what is 8.94 times 4 pi? Three, 4. Okay. All right, so now we'll find the lateral area of the bottom cone. Okay, so now we're looking here. Okay, so we have this radius. We need to find this height.
5.
Okay, how'd you find that so fast?
13 minus 8.
Okay, so that total height is 13, subtracting 8, so that length is 5. Okay, so then we need to find this length again. So I'll kind of do a little side work here. We'll do 5 squared plus 4 squared is equal to L squared. So 25 plus 16 is 30, 41. So the square root of 41?
6.40.
Okay. So then if I take that to my lateral area, would have pi times 4 times 6.4. So what would that be? Pi times 4 times 6.4. 42. Okay, so then we just add the two together. 112.34 plus 80.42 to get a grand total of 192.76 meters squared. So what do we think? Easy? We're getting this lateral, this surface area stuff. Do I need to, what? Cylinders is easier. Well, it's more plug and chug, I think. You have less to kind of worry about. Yeah, I agree. Do I need to do question number 11? The one with the pyramid and the, almost a cube. It looks like the rectangular. Should we do that one?
The same thing, you don't have to add the bases.
You don't have to add, well, you only have to add the one base of the prism. But then you don't need the base of the pyramid. Do you guys want to do that one, or do you feel like you got it?
I got it.
You guys got it? Okay. Awesome, then that is it. I will give